Hi students, welcome to my channel. In this video, we are going to discuss another algorithm design approach, that is dynamic programming. In previous videos, we discussed two algorithm design techniques, that is a greedy approach and another one is divide and conquer. So now another algorithm design technique, that is dynamic programming, we are going to discuss in this video. So mainly dynamic programming is depending on one principle that is called as a principle of optimality. Okay, so what is this principle of optimality? So to solve a problem by using dynamic programming, here we will make a sequence of decisions. We will make a sequence of decisions. So from all those sequence of decisions, we will find we will select one solution as the best solution, which is called as optimal solution, called as principle of optimality. Then what is the main difference between these approaches and this dynamic programming? So if you observe in divide and conquer, so if a problem is very large, for example, there is one problem which is very large, then that problem is divided into subproblem 1, another one subproblem 2, subproblem 3. So if the problem is very large, like that we will divide the problem into subproblems and so on, number of subproblems. Okay, so now in divide and conquer approach, if this subproblem is repeated, then it won't check. This will be solved and again this will be solved. So if the same subproblem here it is repeated, then it won't check whether you have already calculated or not. So in divide and conquer, just blindly divides the problem and finds a solution for that subproblem. Whereas in dynamic programming, what will happen here it is, if it is already calculated. What does it mean? For example, here I have done like a swap of 2, 3. Here subproblem 2, swap of 10, 20. Suppose subproblem 3, again swap of 2, 3. And here we got again swap of 10, 20. If we got subproblems like this, so swap of 2, 3 will be interchanged, then you will get a 3, 2. Swap of 10, 20. So these two numbers are swapped, then 20 and 10. Now swap of 2, 3. So it uses the previous solution. It won't calculate it again by using some temporary variable, interchanging the values. Already you have calculated now. So the same solution will be used here. So again this already you have calculated. So the same solution will be used here. So like that, so what is happening in dynamic program? That's why here it is called as dynamic. So it will not calculate again and again if already that problem solution already you have. So and the solutions are stored for future use. Solutions are stored for future use. That means what is going to happen? No need to calculate. No need to calculate again and again. If that subproblem already solved, just use that solution. Then what is going to happen in dynamic programming? So time will be reduced to find the solution. Time complexity will be reduced. So this is the main fundamental concept of dynamic programming. In the next videos, we are going to discuss the applications where this dynamic programming is used. So like uh, the applications we are going to discuss in the next videos are: one is optimal binary search tree. So this is called as OBST. Second one, traveling salesperson problem. Traveling salesperson problem. Then all pairs shortest path algorithm. Then next one is multi-stage graphs and knapsack problem. Already we discussed in greedy approach na. So here we are going to discuss 0 by 1 knapsack problem. 0 by 1 knapsack problem. These are the applications we are going to discuss in this dynamic programming concept. And another important point here it is, so this greedy approach is using spanning trees. This greedy approach is using spanning trees. So spanning tree construction, minimum cost spanning trees. So Prim's algorithm, Kruskal's algorithm, and Distrau's algorithm, single source shortest path algorithm. So these three concepts already I explained in the subject data structures. These three concepts already I explained in data structures. So please see these three concepts under this greedy approach in data structures subject. Okay, so I already added these three videos in the playlist, greedy approach playlist. Similarly, divide and conquer. For a divide and conquer also, the algorithms or the applications under divide and conquer, one is binary search, then quicksort, and then merge sort. These three algorithms also I explained in data structures subject. So already I have added these three techniques in this divide and conquer playlist. Okay, so why should we again take a video for these concepts, which is time waste process now? So that's why you please watch these algorithms in data structures and these three algorithms also in data structures. These you will get in greedy approach and these algorithms you will get in divide and conquer approach. Okay, so now in the next video we are going to discuss these applications. Hope you understand, students. If you understand this, so please share with your friends so that they can learn. Okay, thank you. Have a great day. Bye.